Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. This episode is a conversation with Rachel Steinberg and Josh Chappell of the Mesa product team at Google. We dove deep into the Mesa Smart Buildings Kit, including its history as a part of Sidewalk Labs, how it works, how easy it is to install, the use cases, business case, and who's using it so far. So without further ado, please enjoy the Nexus Podcast with Mesa at Google. Rachel and Josh, welcome to the Nexus Podcast. It's been a long time coming. I'm glad we got this scheduled. Rachel, let's start with you. Can you introduce yourself, please?
Sure. Yeah, we're excited to be here. I'm Rachel Steinberg. I'm the head of Mesa, which is now a product that joined Google.
Cool. And can you talk a little bit about your background? Like, how'd you get into the role you're in today? What's your background? What's your training? And maybe some past jobs that you've had?
Sure. Yeah, I actually started off in impact investing at the International Finance Corporation. So I was sort of one part of this team that was focused on these small and medium double bottom line impact businesses in emerging markets, and realized all scalable companies had a technology component. So I very quickly switched into tech after that and worked at big companies like IBM, and then a bunch of startups, all focused on products. I was always focused like very much on the product user experience side of building products, and ended up doing a lot of, fintech, and then real estate technology, and property tech, and e-commerce, and several industries, but all focused on the same, like, how do we create better products for customers. And I had studied urban planning in undergrad. So when the Sidewalk Labs product role came up, which was focused on running product for all of sustainability, it was a no-brainer to apply. And fortunately, I got the job. So I was focused on all of the sustainability products, wastewater and energy at Sidewalk Labs. And we saw a gap in the market and kind of pivoted our product to be Mesa. And I was focused a lot on the product side and grew into the manager of the team.
Cool. And I read on your LinkedIn profile, you spent some time in India. Is that correct?
Yeah. So I went to business school and picked up and went to India to build product there for 4 years, which was amazing and great. And I miss it, but it was also an exciting opportunity to be able to understand what assumptions we're making that we shouldn't be making, just especially when you're building products for such diversity in language and culture and levels of technology use. So it was a great, I almost feel like, boot camp and actually building and launching technology for millions of users. Cool.
Well, we have some India-based listeners and subscribers, so shout out to all of them. Josh, over to you. Can you introduce yourself and then give us a little background on how you got here?
Sure. It's great to speak to you. My name is Josh Chappell, and I am the head of engineering for the Mesa team. And I guess my background started in a pretty traditional way, studying computer science, and came out right around the passage of No Child Left Behind. So I got my career actually started in ed tech. To the time, we thought that software could solve every problem, no matter what it was. And I always like to kind of call that out, because that was when I realized that one, software can't solve every problem, that you have to involve people, you have to involve processes and culture changes, and then technology can come and make all that stuff easier. So that's where I got my career started at. And I always like to say we were so successful that everyone did the same thing that we were doing. And eventually that product was bought out. But I love that process. I love the idea of building things and kind of adding to things, which means I immediately went to consulting and got to do none of that. And the good thing about consulting was I got to work with some of the biggest brands in the world and to help solve technology challenges, also government to help solve challenges there as well. And pretty quickly you develop kind of a sixth sense for what will work and what won't work, and how to solve problems quickly, and kind of de-risk at every stage of it. And then once I left that world, I really kind of missed kind of that product experience of building teams and solving challenges over time. I moved kind of back into kind of the startup space, and kind of similar to Rachel, did fintech, did HRS software, which was interesting. Did some e-commerce stuff where it was like how do we create the next best thing that beats the next best thing. But the whole time I always had this kind of burning desire to work in a passion area, right? Like I always cared about the previous areas, but I always wanted to work in something I was like really, really passionate about, which in my case was urbanism, kind of the built environment. And I actually heard about Sidewalk from, I was going to this meetup. It was like this transit techies meetup. And it was like a lot of nerds talking about transit in New York City. And they used to hold it in the same office building as Sidewalk. And then one day I was kind of like, what are they doing up there? Like, what are they talking about? And the more I learned about it, I was like, wow, I definitely have to work here. This is like my dream job. I joined Sidewalk Labs, and then I joined Mesa about almost a year and a half ago, and really enjoyed it.
Awesome. Well, hopefully none of our listeners believe that software can solve every problem, because I feel like that's one of the main themes of this entire show, the entire series of almost 100 podcasts now. I think that's one of the main lessons. That's great. So Rachel, can you talk about, just like give people context on what Sidewalk Labs is or was, and then talk about the transition kind of getting swallowed up by Google that was announced recently?
Yeah, so Sidewalk Labs is an urban innovation company. So we've been focused through our entire history on ways that we can help create more sustainable and inclusive urban spaces. And there's several products as part of it. And the 4 that moved over to Google all have some role to play in creating better urban environments. Okay.
And then can you just talk about we're going to talk about Mesa and go deep on Mesa. What is there besides Mesa? Like what other products are there, and what do those products do?
Happy to give a little more color. So Delve, and I'll say all the names of the products. So first one is Delve, which is a digital master planning solution. So it's focused on empowering developers and architects to meet or exceed financial targets of a project without making trade-offs. So really understanding the master plan and what are all of the options that a developer would have in creating a master plan. Okay. And then affordable electrification. So and we call it AE. So AE, which is a grid management solution. And that's designed to better manage home energy, to be able to reduce both the cost of electrification and pave the way for a cleaner energy future. Okay. And then third one is Pebble, which is a mobility management platform. Okay. Enabling, and what that means is it's a sensor that enables cities, developers, campuses, any big mobility space or curbside management to understand real-time data on parking, space, traffic, and congestion.
Got it. Okay. All right. And so Mesa is kind of the buildings focused product in the suite. Can you talk about either one of you, if you choose which one? You guys can throw this back and forth if you'd like, but go back to the beginning. Why did Sidewalk Labs create Mesa? What problem was it trying to solve?
Yeah, so I can speak to that to that part because I was there through the whole story. What we did at Sidewalk was we were very much focused on how to create an inclusive, sustainable, diverse neighborhood, and that would have all been new construction. And what that meant was you can figure out what is the cutting edge technology or most interesting pieces of technology that you could use, not for technology's sake, but in order to enable the use cases that you want to solve. So we were very focused on being able to create a neighborhood that was just completely, completely sustainable in all aspects. And so I was focused on helping to create the energy optimization solution there. So I looked at a lot of different products, a lot of different offerings, to try to see who we could partner with for new construction on energy optimization. And in that review, the team and I realized that there was a big gap for like the older, 97% of like office stock, some 88% of like the real buildings out there. The older, more budget conscious buildings, smaller square footage. And so what we wanted to do is create the solution that we wanted to see in the market. So we had, we had tested a bunch of different devices, tried to understand what was there, and realized a lot of the solutions out there to be able to both optimize building operations and building controls and overall energy usage are either siloed or really complicated, hard to install. I mean, all the things you speak about on the podcast, and just not a great user experience for all the stakeholders. So when we think of a building, it's like the tenants in the space, the people that are actually moving around in the space every day, and then the operators really managing the building, the asset managers, the owners. And so when you think about all of the diverse stakeholders, it ends up being, a lot of the solutions are built targeting one. And so what we try to do is create the user experience across all those gaps in the market to make something very simple, plug and play, and targeted to an underserved market.
Yeah, I mean, I think this is another theme that's come up time and time again, which is most of the products on the marketplace, historically have been products that were built for an integrator or someone that's been trained in a specific brand of products, or someone that has a proprietary tool that only they have access to. Like, those things are like deeply integrated into the history of this industry. And so what sort of stakeholders were you guys thinking about? I'm assuming it's like an office manager for a tenant, or like a non-technical property manager or facility manager, someone that isn't well briefed or certified or licensed to operate these more technical tools. Is that right?
Yeah. So I mean, I like to say we've built it in a way that there's the high tech components for people that are really interested in that. But in terms of installation experience and end-to-end user experience, it's built for like the non-technical user as much as possible, just to make every aspect of it both interesting and a no-brainer at the same time.
Okay. All right, let's go into what is it? Now that we've sort of set the stage and drawn up the context, what is it? What use cases does it enable? What does it do?
Okay, yeah, I'll speak to what it is, and I'll let Josh speak to some of the use cases, and we'll probably point back and forth as we trade off a little bit. But Mesa is a lightweight building control solution that's intended to help buildings optimize on operations, on costs, and especially on sustainability. So it enables all buildings to be greener, more affordable and cost effective, as well as increased value and just more comfortable for the tenants. And a little more specifically, because I feel like a lot of times when you read websites, they all sound the same. It's a mix of sensors and smart devices with a really smart back-end engine that helps to optimize HVAC and plug loads and surface any issues within the building as well.
Mm-hmm. Okay. Josh, I want to ask you about use cases, but first I want to hit back on, so you mentioned lightweight, Rachel. What do you mean by lightweight? What's that word mean?
So when a customer gets a Mesa kit, what they get is a set of very tiny, almost like Scrabble piece size or stamp size sensors, plus smart devices with a full map of their floor plan. So all of these sensors have an ID on them, and people are kind of taking them out of the box and literally like sticking them on the wall at certain places based on that floor plan. So in some ways, I kind of say it feels a bit like paint by numbers, or, it's as easy as just like follow this map.
Okay.
In fact, my colleagues, 4-year-old and 7-year-old, did an install in their home office by themselves. So it's, it's intended to be quite easy. The most complicated thing is, re-terminating the thermostat wiring for the smart thermostats. And otherwise, everything is pre-commissioned, pre-identified. And so it really is they like stick things on the wall, plug things in, and you look at your dashboard and everything is running. And then the system automatically starts to save on heating and cooling and ventilation, as well as on outlets. So what I kind of was implying by lightweight is that it's a very simple and easy installation process and gives a lot of information to the occupant and the operator right away.
Got it. Okay. Yeah, I have a couple questions on the install process, but maybe let's circle back on that in a minute and talk about use cases. So what use cases is this? Can I call it a kit? Do you guys call it a kit? I'm like picturing what I saw on the website, which is like, I get this box of all these things that comes in the mail. And then like you just said, there's a map for how to install it. I have this kit. What does this kit enable me to do? What does it enable the end user to do? What value prop is there?
Yes, definitely you can call it a kit, easy to use kit. So the first use case and our number one goal is energy reduction, and by proxy energy reduction, carbon reduction. I think we've all seen the statistics of, even as commercial office spaces, which account for as much as 40% of energy use, even as they were empty 70-80% of the time, the energy reduction was only 30-40%, which means that a lot of energy was being used for essentially empty spaces. And the problem is, in order to save that energy, you have to understand the space in ways that many current technologies either don't allow for or don't allow for easily. So, if you think about what comes in the kit, we have spatial sensing in terms of occupancy, where are people at in the space, when did they get there, and kind of what patterns emerge from that. And that lets you tackle a whole list of other ways to optimize the energy. But basically, you only need to make a space comfortable when people are there. Another thing that gets in the kit is the comfort buttons for feedback. It's fascinating. You ask everyone their experience in a commercial space, and the number they always say is, my office is too cold. My office is too cold. And that's because, the feedback chain from a person actually occupying a space all the way through to an operator who's running it in good faith is actually quite long and quite complex. And so if you say you're cold on Monday, they can't change it on Wednesday afternoon. But by actually providing input mechanisms within the space for the occupants to provide feedback, then it actually can say, okay, everyone's saying they're cold. We've seen this pattern a little bit. We can probably raise the temperature of a space, and not only will people be comfortable, in most cases, you'll actually save energy. You can actually save substantial amounts of energy that way. Another thing Sensor use is detection of doors and windows, where it's actually amazing that in a positive pressure environment, a single window open on a floor can affect the thermal characteristics of the entire floor. So knowing if those windows and doors, exterior windows and doors are open is actually really, really important. And you can imagine in a sufficiently large commercial space, let's say there's 100 windows, 200 windows, one being open is really, really hard to kind of troubleshoot. But the beauty of those really small, long-lived wireless sensors is that you can have full connectivity to your space at all times. And that's another way of driving savings in the space. So, and then another piece of that is, once you have all this sensor data, the ability to consume all of that and to use machine learning and artificial intelligence to drive better outcomes. So, for instance, if you're seeing that everyone leaves roughly between 6 p.m. and 7 p.m. in the evenings, traditionally, operators will heat or cool a space up until the very last moment they expect someone to be there, because you kind of have to be. But we can say, actually, you can begin raising the temperature of the space around 5:30 and achieve the exact same outcome while saving energy. Or if you detect that most people arrive around 7:30 a.m. in the morning, we're all familiar with preheating and pre-cooling, but typically you have to, the night before or on a fixed schedule basis, determine what those intervals of time are. And Mesa can actually say, well, actually, based on the weather tomorrow and the predicted occupancy patterns, we can know the exact moment that the system should start heating or cooling space to achieve a certain target. And it's really hard to do that, at the human level, but computers are really good at doing boring things. So our number one goal is always energy reduction and carbon reduction. But what you begin to find is saving energy. Luckily, often it goes for tenant comfort as well, which is another use case for us. And I think you combine all these pieces together, you get like a system that you install the kit, it learns from how people use the space, and you just get a more comfortable space that saves energy, which is really nice.
Cool. Yeah, I mean, the way I'm hearing it, like the value I'm hearing is you have a bunch of these devices, and for lack of a better term, we got a bunch of devices in a space. Not all of them are digitized most of the time, right? So what I'm hearing is you have a low cost, kind of easy to install way to just create data, right? And the ability to control stuff. So I think I heard plug loads, lighting circuits, thermostats, right? So those three end uses, primary energy consumers in a building. The ability to quickly get data from those and control of those sounds extremely powerful.
We don't yet have lighting, but it's on the roadmap.
Okay, got it.
Only HVAC and plug loads and lighting to come. And then there's a couple other use cases we've just started testing, or we've just actually launched around air quality and even leak detection.
Okay. Yeah, I was going to say that the other piece of that is not necessarily devices, but adding data. So you mentioned occupancy data. Now you're talking about indoor air quality data. The ability to have all of these things sort of pre-integrated together sounds super valuable. The other piece of this is like the status quo in our industry right now is to install a bunch of point solutions for all these different things we're talking about, right? So it seems valuable in terms of just this is one kit that covers occupancy, IAQ, controls over certain things, windows, status, that sounds like as well. Is that kind of the idea? The strategy is to kind of, number one, digitize stuff that isn't already digitized, but number two, kind of make it pre-integrated and not need an integrator.
Yeah, and overall, the way that you described it is accurate. As we continue to add more or serve more use cases for our customers, they won't need to install a new gateway or they won't need to install a new system. If a customer that we're already serving says, hey, we actually want your air quality solution, we can just send them that piece of the stack and same install process, and it's all right there on their dashboard and ready to go. So they don't need to go through a whole new process.
Okay.
But
cool.
Yeah, all pre-integrated already.
Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview. Yeah. Can you guys talk about just maybe some examples of the install process? Like, I mean, I already said it, you get a kit in the mail and you have instructions, but like talk about some of the actual users and the people that are actually out there installing this today. Like, do you have any good examples or good stories?
Yeah, so I'm happy. Do you want us to share more on the installation process or kind of what some of our customers have been experiencing, or both?
Yeah, I think both. I think just what I'm looking for is context around this new way of installing stuff. Like, I think this audience is sitting here and going, well, I got to call my MSI and get my design engineer to draw some drawings up and like all this stuff. Like, talk about how it is instead of that. You know
yeah.
I mean?
So, and that's definitely a pain point that we're trying to solve with this, and especially because people are doing a million other things and we wanted to make it as easy as possible for everyone to have access to cutting edge controls. And so what we would do as part of the sales process is understand the HVAC equipment and the systems in the building to vet and make sure that it's compatible as a start. And then it really is as simple as we have the floor plan for the space. Sometimes we also do a video call with them and draw up the floor plan if they don't have a pre-existing floor plan. So we try to make that process as simple as possible too. Then we'll show the customer exactly where each sensor is placed so they can talk through like, okay, does this make sense? And then that's the floor plan we go with. So all of the sensors are pre-laid out with certain IDs. So you could see, let's say, the proximity sensors on the windows. It'll have a certain 2-number ID on it, so everyone knows, okay, this ID goes in on this window, and things are organized in the box, and they just stick it on the window, and then they'll go to the motion detection sensors and do the same thing, and place those in the spaces that we allocated. Same with the smart plugs. Same with really each of the sensors. It's as if I kind of feel in some ways to not at all to diminish the process, but it kind of to me feels a bit like a game, because you're kind of like looking at a treasure map and placing things on your space, and it's intended to just be that easy, because buildings have a lot of other things that they need to be worried about and not worried about an installation process. And so that's why we do all the work on our side to pre-commission, to pre-integrate, to put everything, all these otherwise siloed devices into one place for the customer. And then start seeing them right away. Meaning saving energy, optimizing the space right away.
Okay. Cool. Josh, you mentioned tenant feedback to comfort. And then you also mentioned AI for, sort of optimizing energy usage sort of behind the scenes. It strikes me as those two things kind of could be in conflict, right? How do you well, first of all, can you talk about how that works? So I'm assuming there's the tenant has some sort of application that they can give feedback to the system on, but then how does the control work? It sounds like there's a thermostat that you can then take control of and change the set point on that. Is there any other integration with any other systems that sort of optimizes things?
Yeah, so I think, in terms of the tenants providing the feedback, there's both an application as well as physical hardware buttons that are kind of deployed in the field, where they kind of say it's too hot, too cold, and that provides a kind of a tactile way within the space to kind of provide feedback on it. And yeah, as you can imagine, I think the best way to think about the kind of the optimization system is, we get in a series of a lot of signals kind of coming into it, and then we try to use those signals for the greatest effect. So for example, if you're, and we've seen this a lot, right, in the real world, where, if 10 people are saying we're hot and 10 people are saying we're cold, and we kind of see that over time, you say, well, which direction you go to? And then in that case, we may say, well, actually, we need to provide feedback to the users of our space and say, as an insight, folks who are saying they're cold, they're actually warmer spaces within the same floor or in the same building. Folks who are warm, here's the opposite. What you tend to find is that the trends do tend to show up, right? So usually we'll see an 80-20 split of cold or hot. In those cases, we take that as a signal to the system and say, well, we can, reduce the temperature or raise the temperature. And in most cases, believe it or not, usually you'll save energy. So if you think about traditional operations, you kind of have to overshoot your target, because, if you want a space to be warm in the morning, then an operator needs to set a set point at night, and vice versa for cooling. Whereas Mesa can say, well, we don't have to kind of overshoot in order to have a comfortable space. So, people get into an office in the morning and it's really, really cold because it knows there'll be more people later in the day. Whereas we can actually say, no, let's actually progressively cool the space in a really intelligent way, based on our knowledge of occupancy and based on the feedback we're getting from people to say, this actually be comfortable. So there actually isn't as much disagreement because tends to be the more energy efficient solution, the thing that people want. And the missing piece that Mesa provides is that really intelligent control authority where we can say we can achieve a better outcome more efficiently.
Okay. Yeah. So can you guys also talk about the tech stack? So I'm thinking about like, if I have, you guys talked about occupancy sensors just as an example. What if I already have some sort of IoT occupancy sensor stack? Can you use that data in everything else you're trying to enable? And then the second question would be like, if there's something that's, say you have Mesa installed in a tenant space, but you need to like provide data up to the bigger, larger building and maybe even the portfolio. Can you talk about how this sort of stack that you've described sort of sits in context with other technologies?
Yeah, so in terms of the hardware integration piece, a lot of it really kind of depends. One of the things that's really exciting is we're always adding new partners and compatibilities. Like we view success to us is the greatest amount of compatibility with the most number of places and most number of users. So we're always looking to add new partners. And in terms of getting data out of the system, that's something we're also just working on. Is we don't want to be kind of this siloed, locked vault of spatial data. The idea is that this should be providing value to you. So if someone asks, it's like, okay, well, we can provide this data in a report or an alert, but if we can't, then how can we actually make that data available to third-party systems? Because we think that's another, historical difficulty in space is people tend to want to lock up data, whereas we view it as, we hope that we're going to do such a great job optimizing your space that the data piece of it is more, it should be value add for you.
Okay. Let's talk about the go-to-market. How is this thing sold? It sounds like what I'm hearing is it's definitely an option for a tenant that like only has control over their own space, and they have a thermostat and they have plug loads and they have windows, right? It sounds like something that they could easily install in their space, the part of the building that they own, and sounds like a great fit. Are there other applications for, say, the landlord, or how do you guys sort of go to market?
Yeah, so most of our customers are actually the landlord.
Okay.
So it is very easy and simple for the tenant to install it, and we do have some great like tenant customers, but overall, like landlords have been quite interested in offering this as an upgrade for their tenants to their tenant spaces, enabling their tenants to both be more comfortable and regardless of who pays the bill, because in both cases it ends up working out, either saving their tenants more on their electricity bills and just overall making sure that, especially with work from home and in places where there's less, just like a less 9 to 5 workday, we're generally making sure that people are not just overspending and literally like throwing money out the window. So yes, offering for landlords, offering for tenants, and overall at scale. So what landlords have been enjoying is being able to put it in, a floor or one of their buildings and then extend it to other buildings as they want to upgrade some of their other spaces. And then they can see everything on the same dashboard.
Cool. Another application here I feel like is for smaller buildings. Can you talk about, like, I like to like sort of start to separate out the conversations we have on this podcast, because it's like some of them are only applicable to the biggest, most expensive, most well-funded buildings. Right. It sounds like this can apply to the smaller buildings as well.
Yeah, we love serving our smaller building customers. So in general, it's intended to be completely modular. So it can serve like the big fancy buildings, but in many ways, the sweet spot of where it works nicely, especially because it's quite affordable, is those smaller buildings, so that the smaller buildings can have controls, maybe even more controls and more data than some of those big fancy buildings would have.
I'd actually guarantee that, but
I know. I mean, we've seen a lot of examples of both buildings, so
Okay. Well, let's talk about examples. So do you guys have stories you can share on sort of, I don't know how long this product's been on the market, but I haven't been in a building where this has been installed yet, but
Can you talk about some stories of some sort of traction you guys have so far in getting this installed and some results?
One interesting installation example has been in schools, for instance, where it's a lot of enclosed zones. They're very sensitive to energy use. They have kind of a regular predictive cadence on when people are going to be there. And, that's another example where the ease of installation is a huge time save for them, because it's like an old solution where in one case it was literally a librarian doing it, doing the install, where she's like, I'm not really big in technology, but if you can follow instructions, you can kind of install it, which is really useful. And and they save energy, right? Because most schools kind of operate roughly the same every single day, which obviously, Saturdays and Sundays, no one's there, and then the nights and mornings. And in another case where we have a published case study for, which is in a building with Heinz, where that is a 100% a Class A building. They have a sophisticated EMS there, but what we found is there still was those gaps in that kind of in their ability to optimize the space there. So, for example, you mentioned, everyone you see now pretty commonly. Lights operate with motion sensing, but believe it or not, like the motion sensors in those lights don't interoperate with any other system in the building. So the lights one's there, but your HVAC doesn't. So what we found was, we deployed window sensors for windows, because what they found was people would leave windows open in spaces, causing bills to go up. And then we deploy sensing for HVAC to only cool and heat zones when people were there. And then another interesting use case came up where, if you actually monitor a physical space and all the equipment connected to it over time, things like fault detection become a lot simpler. Where we can say, actually, this piece of equipment should be functioning more efficiently than it is. Let's take a look at that. Or, this space, the air exchange rate should be higher than it is. And that's one of those cases where it's like, wow, we didn't really know this. And then, of course, and also for plug control, that's also another great case study that came out of the work with Heinz, where, as in most modern office spaces, you walk in there, there's 15 televisions on, they're all 70 inches, there's hot tea brewing, they're waiting on you. And what you begin to find is that a lot of these workloads, it adds up really, really quickly, where the energy it takes to keep water near boiling all the time, or you walk near your television and you're like, wow, this room is really warm. And you're like, yeah, the television's doing that. So doing plug controls there has saved
interesting
megawatt hours of energy. And I think that's kind of one of the exciting things, that just the installation of smart plugs and kind of cloud smarts can achieve that. And we've seen that as well, the plug example, as well as in schools as well, where, everyone's using smart boards and doing installs there. And the beauty of it is that the screens turn off when everyone's gone, and they turn on right before people arrive. So no one knows that it exists. So earlier you mentioned you hadn't seen it. I was like, well, hopefully no one ever even knows that it's there, because things are just in the background. I'm trying to think any other interesting installations we've done.
Some comfort ones. I mean, the other thing that's been cool for me, because I am always cold in spaces, to see is always on the comfort side, especially as Josh was saying, like most of the time it aligns with saving energy. But in some cases, for example, if there is a persistent problem and there's one person within the space that complains and everyone else is comfortable, it makes it a lot easier to identify what are the changes within that zone, within a day, within different weather. And once you can understand that granularity, you can suggest even like, okay, in this case, we can do everything we can on the HVAC side, but the truth is you might just need to get an additional desk fan, or, a plant in certain cases, or whatever we're trying to control for. So it's been cool for us to be able to surface some of those insights in ways that then really do help the targeted, help like create more targeted comfort in places where it's almost impossible to do an HVAC solution comfort, almost to do something at like the greater equipment level.
That actually reminded me of a recent case that came up where, earlier I mentioned that technology kind of isn't the end all be all solution to it. It's kind of like a tool to use. And as Rachel mentioned, in addition to the automatic optimization happening in the background, and then of course there's like the operational dashboard, we also have monthly insight reports that sent out to customers. And one of them recently was, like Rachel mentioned, there was a specific room in a space where they were consistently colder than all the other spaces. And the person kept hitting cold and too cold and too cold, too cold. And the system is like, we're doing everything that we can. And the insight report was like, we think there might actually be a airflow issue into the space, because, all the adjacent volumes are reaching the desired temperature really, really quickly. And what we found was that during the summertime, the room was being overcooled because this was pre-Mesa, and they closed the vent in the room to keep it from being overcooled, but they never reopened it for the wintertime. And they went in there and they're like, oh my goodness, like we've been like broiling other rooms just to heat this one room when it was never really ever going to work. And that only works when you have sensors in every single space. And in that case, we actually were able to install more sensors to kind of even add more kind of data around it. And those are the use cases I get most excited about, where it's not just a machine making a decision, it's a machine noticing something and then informing kind of a human user, and that kind of empowers their work.
Totally.
And just to add on another, other fun insights is like there's times when the system is like the windows are open, and the customer's like, no, they're not, but they weren't really in the space. And then finally, when they check, they're like, actually, yes, they are. So there's always these like small things that come up in addition to just like the background, easy, just save money, save energy that's going on.
Yeah. Well, I'd love to follow up just a little bit on this story. So you're mentioning how it's coming up with different alerts related to whatever data you have, right? But the way I heard you guys talk about the stack, it's not like you're not connecting into the broader building automation system, are you? You're just putting in sensors that you guys installed and then using those to sort of do sort of like a lightweight, there's that word again, lightweight.
Like the one you want to use, but it also has very little.
It has a negative connotation a little bit, but
I know, yeah.
But it sounds like you're able to do analytics, what I would call analytics, which is basically the data that you have available. What insights can you gain from this data? But what you're not talking about is connecting in, like the room you talked about. You're not connecting into like a VAV box that's being, that's feeding air to that room. You're just putting in a sensor and maybe other sensors that you guys install.
And thermostat controls. But Josh can also speak to roadmap stuff of like the increased integrations.
Yeah, but yeah, so just to put a platform on it, yeah, indeed. So our sensor layer can measure. So you typically, for every kind of enclosed volume, we'll deploy some notion of occupancy, humidity and temperature sensor, and then if it's being served by a thermostat or a control mechanism, we'll integrate that control mechanism. But believe it or not, you can actually develop a pretty comprehensive model of a space just with those. If you measure, so for instance, we can say, okay, the room is currently 70 degrees Fahrenheit. We want it to be 72, and if you measure how long it takes to reach that set point with no one in there, and you measure how long it takes to reach it with someone in there. If you look at time of day, if you look at outside air conditions, then you can kind of make certain kind of informed assumptions around that. And we also know about certain spatial adjacencies. It's not a huge part of our model, but it's one of the things kind of working on. And that can also tell you about like thermal leakage, or rather thermal transfer between spaces. We get kind of two signals, which is we know what we're attempting to do, and then we can monitor the space, see how well it's being done. And then in that delta is actually really informative for us. And so then we can use that both to train the model moving forward, as well as to create those insights and say something is unachievable about this space. And the cool thing is it's not just we deploy a technology solution and then we kind of walk away. We have a customer success team where we actually will speak with you to understand your space, understand your use cases. And that's where we kind of say like, hey, by the way, is there like a vent closed here, or is there some kind of funky going on? And I think that's actually the kind of that third piece that really adds a lot to it. And then we've spoken this a little bit earlier, but we do have the ability to integrate with, and we are continuing to build out our stack so we can integrate with systems that have more complexity, such as VAVs, AHUs, rooftop units and things like that. And that's where those use cases around things like fault detection are interesting, or airflow mixture interesting. And that's actually a good segue for some of the IAQ work we're looking at, because our view is we want to be able to integrate with just the most of our systems possible, because there's opportunities everywhere.
Got it. Very cool. So what's next then? So I've heard more integrations. I've heard indoor air quality. Can you talk about the broader roadmap besides those two things?
Sure. So I always look about what's next. But so as you mentioned, so for instance, air quality for us is not just the traditional static reporting of like, here's the CO2 ppm of a space, because I think everyone's looking for how do we turn this data into something actionable. But for us, we also get it as another signal, right? Where during a lockdown, the behavior of most spaces was to let's just crank up our air recycle rate as high as it can possibly go. and as a way of trying to reduce particulates in the air. Whereas you can say, well, actually, if you deploy air quality sensing in the space, we can actually fine tune that so you aren't wasting energy to achieve no effect. So for us, it's about every sensor we add, we want to incorporate it into the broader picture of how to operate spaces more effectively. And so in addition to air quality, as Rachel mentioned, we're also deploying leak detection. And that's around, folks are saying, we love the dashboard, we love the integration. How can we also solve more and more challenges? And we're like, we understand all this stuff about your space. So adding things like leak detection and the presence of water is pretty straightforward. And it's something where you can add it to your existing alerting stack. Those things that are coming up. And then all the use cases around that. So for instance, people have said, if we have these great smart sensors, what if we put them in refrigerators for cold chain, stuff like that? So these are things that we're looking at rolling out in 2022. And in addition to that, as you mentioned earlier, like for compatibility with different types of units, we mentioned things like VAVs, but also like VRFs, where we really just want to be able to integrate with as many systems as possible. And then the last one is for obviously deploying sensors into our space and making it really, really easy is like a kind of key part of the value. But we also think kind of the really interesting piece is like this really smart AI engine that kind of sits in the middle of it all. And we pair that with buildings that maybe already have a sensor strategy, right? So let's say you are still Class B, so you're not brand new, but you've already done kind of a rollout of smart sensors in your buildings. But what you're beginning to realize is that technology alone doesn't actually solve much. We're like, well, actually, let's integrate to your sensor feed, let's integrate to your control plane, and let's do all the operations pieces. And that's something that's actually been really interesting to build out, because that's where you actually can start getting some of those kind of wins and spaces we couldn't do before.
Got it. All right. I think the last question I have is around the pricing model. Is it a subscription-based model? And then can you also talk about, as a subset to that question, like how your customers are thinking about ROI? How are they thinking about how to justify this investment? And let me caveat that with, like, this is one of the main questions I get from beginners. So we teach this foundations course. It's for like beginners to the industry. We're about to start a new cohort here in the next couple of weeks. And it feels like the students are like, their appetite for examples of the business case cannot be satisfied. It's like tell me about how.
I appreciate that.
So yeah, I'd love to hear how you guys or how your customers are kind of thinking about justifying the investment.
Yeah, so in general, it's very straightforward because we do cut energy bills. So it is very straightforward of a very clear payback within a couple of years. And depending on the building, some buildings we've seen them save quite a bit in certain cases. So there was a lot of, there was a lot we could do, and it could happen quite quickly. So I think in that case, it's super straightforward ROI of just like you get the money back pretty quickly, especially for a building technology product. And in general, what we've done to be able to make the ROI as enticing as possible is every single piece of the product has been vetted for very high standards. So what that means, like, every piece is affordable by design to get the biggest bang for the buck across the board. And so that includes like practically no maintenance whatsoever. Battery lives that would span several tenants, 10 to 15 years, things like that, where it's just, it truly is everything is as high standard as possible without overdoing it. Well, an example of that too is we looked at, do most spaces really need occupant counting? Some spaces might, and they could ask us for that, but we did a bunch of tests, and in terms of being able to save money and save energy, it seemed like the prevalence of the motion sensing that we offer is great for that, and you don't need to go to a much more expensive, people counting type of solution. And so each piece of the kit really is focused on how do we get the best ROI, and the ROI really starts with the install process. Like, you don't need days of expensive installation to get it up and running. It's like right away. And that's part of why the installation process is so easy, because we care so deeply about ROI and affordability.
It sounds like it's not strictly subscription. There's some upfront costs to buy each sensor. Is that how it works?
Yeah, so we have an upfront hardware cost, and then we have a monthly subscription fee as
Got it.
well. And frankly, it's honestly, I mean, I don't know if I should even say this on the podcast, but it's so affordable that most customers are like, yeah, we just want to pay for everything up front. So so I don't
I think
know.
you should say that. I think we need to be talking about how much stuff costs more openly. I've heard that a lot of feedback from our listeners, our readers, is just like, what if, like the broader enterprise SaaS world, right? You go to somebody's website, Zapier. I just got done using Zapier. I use it to automate a lot of the back end of Nexus. A company like Zapier, you just go to their website and you click on pricing, right? And how often do you see that for software tools and hardware tools in our industry?
I'm a big proponent overall, so I won't even like start on this topic too much of just like the fact of like SaaS, enterprise SaaS trends bleeding into especially commercial real estate offerings. Like I do believe over time we're getting there. So I think that to me, that is part of the trend of like everything we've learned and seen in that industry will start to bleed into expectations.
Yeah. And I think in order for companies to do that though, they have to like get all of the manual labor and the unknown integration stuff sort of out of the process at some point. So, all right, cool. This has been really fun. I learned a lot. Let's close out by sharing some carve-outs. So I'll go first. So I'm going to kind of recycle. Yeah, I'll give you guys some time to think of yours as I share mine. If you're listening on audio right now, Josh and Rachel are just laughing because they're caught off guard, I think.
At each other on who's going to go first on it.
Okay,
so.
Got it. No pressure. This is supposed to be a fun way to end the show. So my carve out is my hot water heater is dying. It's 18 years old. And I've been having plumbers and electricians into the house to figure out how to replace it with an electric heat pump. So I've been going down a deep rabbit hole on heat pumps and specifically heat pump water heaters. And it's like, how noisy are they? Like, where do they get their heat from? How does it work? How big is it? Is it going to fit in my existing space? And what I want to send people towards is the book Electrify. So basically, it's a book that was written by Saul Griffith. I'll put the link in the show notes. It was in this week's newsletter as well. It's a great book. It's not technical, but it's arguing for the fact that every time someone's natural gas burning device or other fossil fuel burning device dies in their house or building, he's basically saying that everybody then has to take that decision that I'm trying to make, which is to go electric. And we have to do it at like 100% from here on out, essentially. So that's my rabbit hole. We'll share that book in the show notes. Definitely recommend it for people. All right, which one of you wants to go first?
I'll do it. I'll go. When you started saying yours, I was wondering if you were just going to go like the cold shower route, like go, the Wim Hof style, just fully like cold showering. So
I do take cold showers, but not at the beginning of the shower. But you have to like start off with heat, but then switch it over halfway through or so. But I'm a definite Wim Hof fan for sure.
I guess I'll go there's a book that I always go back to in terms of just team culture, and I'm a big believer in just like great culture for teams and creating supportive teams. And so the book that I like around this is called Culture Code by Dan Coyle. And It's very much focused on like high performing teams and what they have in common. And so that's my go-to rec on teams.
Nice. We'll put that in the show notes as well. How about you, Josh?
Oh boy. So just for background, as a team, we do weekly kind of recommendations in our meetings. It's kind of a way of like getting to what people are doing. And I'm always comically the worst at this activity. I'll think of something later, like an hour later, and think, I had a great recommendation. So I'm just going to completely punt on it and do what I'm reading at this exact moment, which is a book called The God Equation by Dr. Michio Kaku. And what's fascinating about it is like there's a lot of like cosmology books around like the unifying theories of physics. And there's lots of interesting ideas around it, right? But I actually like this book kind of focuses more on the pursuit of the question or the pursuit of the answer rather than the answer itself. Obviously it posits certain answers or certain possibilities of it, but I think it's interesting because it has kind of it has maybe kind of fallen in love with the questions again rather than the solutions for them, because I think sometimes like engineering we're obsessed with solutions, and also enjoying the pursuit of them. So I think that's kind of it's been kind of a fun reminder to me to enjoy the process of solution finding.
Cool. We'll put that in there as well. Well, thank you both for coming on the show. I'm glad we did this, and we'll talk to you next time.
Thank you so much. This was great.
All right, friends, thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.